Question 10. Use an augmented matrix to solve the following system of equations. So the first thing to do is to actually write out our augmented matrix. Again, the augmented matrix is simply the coefficients of our two equations here. So we're going to have 3, a -6, and a -9. The second row will have a -2, a -2, and a 12. The line in for the equal sign, and we're off. Our goal is to make a matrix that has a 1, a 0, a 0, and a 1 with the line and then numbers over here. Those two numbers will end up being our solution. So the first thing we want to do is make this top number a 1. To do that, I'm going to multiply the top row by the reciprocal of 3, which is 1/3. So I'm going to do 1/3 times the first row. I'm going to leave the second row completely as it is. So our new matrix, 1/3 times 3 is 1. 1/3 times a -6 is a -2. And 1/3 times -9 is going to be a -3. Again, our bottom row now stays the same of -2, -2, and 12. Our next step is going to be to get this -2 now to a 0. To do that, we're going to multiply the top row by the opposite of -2, which is 2, and then add that to the second row. So we're going to take 2 times R1 and then add it to R2. Since we only want to change the bottom row, we're going to leave the top row the same. So we're still going to have a 1, -2, and -3. Now we're going to apply our rule here to our old matrix. So 2 times 1 is just going to be 2, plus -2 is 0. 2 times -2 is a -4, plus -2 is going to be -6. And then a 2 times -3 is a -6, plus 12 is a +6. So now, our next step is to get this -6 to be a 1. To do that, we're going to multiply by its reciprocal. So we're going to do 1/6, but it's going to be a -1/6 because this is a -6. A negative times a negative would end up being positive. We want that +1. So we're going to do -1/6 times R2. So our new matrix, the top row is going to stay the exact same with 1, -2, and -3. Our bottom row now, after we multiply through by -1/6, -1/6 times 0 is going to be 0 still. -1/6 times -6 is a +1. And -1/6 times 6 is a -1. Next step is to get this -2 to become a 0. To do that, we're going to multiply the second row now by its opposite, which is 2. So we're going to do 2 times the bottom row and add that to the top row. Since we're now changing the top row, our bottom row is going to stay the same. So I'll write in the 0, 1, and -1. And now we're going to apply our rule to the old matrix to change the top row. So 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus a -2 is 0. And 2 times -1 is -2, plus a -3 is -5. So we now have our solution matrix. We have x equals -5 and y equals -1. Again, these are now our coordinates of where these two lines that we started with way back at the top intersect. So our solution is always an ordered pair. So it'll be -5, -1.